Hello students, I am Kulesh Chandra from Jigyasa Educational Channel. I want to greet you with a new video about electricity. It is an important chapter of class 10 science according to syllabus prepared by CBSE and other state boards. It is included in the physics part of class 10 science. Electricity is very important. It is a good and important source of energy. Without electricity, no modern life is possible. If you see everywhere, we can see the use of electricity. Without electricity, nothing can be done. It appears like that. So electricity is a very important source of energy. No modern life is possible without electricity. From our home to factories, from our day-to-day life to public life, in our domestic works to transportations, we see the use of electricity everywhere to a very large extent. So electricity plays an important role in the formation of modern civilization, modern industrial civilization. In our domestic life at homes, what happens? We use light, operate fans, heating purposes also, an iron, heater, oven, to run computers, charge mobile phones. We use electricity extensively. In the industrial sector also, electricity is extensively used to run various machines they needed for their various purposes. Similarly, in the field of transportation, electricity is used to run the electric trains. So, if we notice that electricity plays an important role in every part of our life, in every section of our life, as well in our private life as well as public life. In this series of video, we will discuss a lot about electricity according to the syllabus prepared by CBSE. In this series of videos, a number of videos, we will discuss the following topics: electricity, electric charges, electric potential, electric current, electric power, heating effects of electricity, and also a number of other things related to electricity. So students, let's come to the main points. Electric charges is an important thing, topic to discuss before going to study what is electricity and its extensive uses. Let's discuss that important topic, that is electric charges. We begin this discussion with an activity. Let's start the activity. Number 1. Take a plastic comb. Bring the comb near some very tiny pieces of paper kept on a table. It will not affect the tiny pieces of paper in any way. You will notice no attraction towards the pieces of paper by the comb. Now, rub the plastic comb with your dry hair. Thereafter, bring the comb near the pieces of paper. Now, what will you see? You will find that the comb attracts the pieces of paper. What helps the comb in attracting the piece of papers? We can say that initially the comb was electrically neutral. It has no charges. Hence, they could not attract the pieces of paper. When the comb is rubbed with your dry hair, it helps your comb to get electric charges. Then, this electrically charged comb has got the power to attract the pieces of paper kept on the table. We can do the same type of activity, taking a glass rod rubbed with silk cloths, or an ebonite rod rubbed with woolen cloth also. The glass rod and the ebonite rod have the power of attracting the pieces of paper, like we saw in the case of rubbed comb, which has the power of attracting the small pieces of papers. Ebonite, its other name is vulcanite or called hard rubber. It is attained by vulcanizing natural rubber for a prolonged period. It may contain 25 to 28% of sulfur and linseed oil. The name ebonite comes from the intended use of an artificial substitute for ebony wood. It may be called synthetic resin also. It is a hard polished rubber obtained by vulcanizing rubber with a large amount of sulfur, used for the manufacture of combs, buttons, and electric insulations. Two types of surges. Experiment made on electric surges reveals that surges are of two types. One is the positive charges, the others are negative surges. The above activities, the surge acquired by the glass rod when it is rubbed with cheap cloth is called positive charges. On the other hand, the ebonite rod acquires surges which are called negative charges. So charges are of two types, positive charges and negative charges. There is an interesting property of charges, that is opposite charges attract each other while similar charges repel each other. It means a positive charged particles attracts another negatively charged particles. Similarly, a negative charge attracts a positive charge. But when the charged particles are of same nature, there will be repulsion. A positive charge repels a positive charge, or a negative charge repels a negative charge. Thus, opposite charges attract each other, and similar charges repel each other. The SI unit of electric charges, the SI unit of electric charge is coulomb. It is denoted by capital C. We can use capital letter C to represent coulomb, which is the unit of charge, SI unit of charge. 1 coulomb is that quantity of charge which will exert 9 to 10 to the power 9 Newton of force on another charge of equal quantity or equal strength. When they are kept at a distance of 1 meter, that means if you take two charges of 1 coulomb at the distance of suppose this is a charged particle having 1 coulomb charges and another charge, it has also 1 coulomb of charges. If they are kept at the distance of 1 meter, they will exert a force which is amounting 9 into 10 to the power 9 newtons. This is the definition of 1 coulomb of charge. We know all the metals are consist of the different atoms. Actually, they whether it is an element or compounds, they are formed with a small division called molecules, and each molecule contains some one or more atoms, and all atoms have the element. Two types of charged particles. All atoms of element like hydrogen, oxygen, nitrogen all have two types of charged particles in them, and another also electrically neutral particles, and these are proton and electrons, and the neutral one is a neutron, and electron has the negative charge and a proton has a positive charge. That means the positive charged particles is called the proton and the negatively charged particles is called electron. So what happens, a proton has 1.6 Newton minus 19 coulomb of positive charges, while an electron has 1.6 into 10 to the minus 19 negative 10 to the power 19 coulomb of negative charges. It is in that both proton and neutron possess the same amount of charges, but the nature of their charges are totally different. Proton has the positive charges, and while electrons has a negatively charged particles. So but the amount of charge held by them is the same, although they are opposite in nature. Let's count the number of protons or electrons that may contain in a 1 coulomb of charged particles. Let's start. Now we know the number of let's count the number of electrons present in 1 coulomb of charges. We know that the charge of one electron is 1.6 into 10 to the minus 19 coulomb. In other words, when the charge is 1.6 into 10 to the minus 19 coulomb, the number of electrons will be 1. When the charge is 1 coulomb, what will happen? The number of electrons will be 1 by 1.6 into 10 to the minus 19. Since 10 to the minus 19 is in the denominator, what will happen? And the next step we find that it will be 1.6 into 10 to the power 19. Since 1 by 10 to the power minus 19 is equal to 1 by 10 to the power 19. That means 1 by n a to the power, sorry, a to the power minus n means 1 by a to the power n. Therefore 10 to the power minus 19 means 1 by 10 to the power 19. Again it will be 1 into 10 to the power 19 by 1, that is equal to 10 to the power 19. So it is written as 10 to the power 19. Now what will happen? To remove the decimal, we multiply it by 10. So what will happen? 1.6 is multiplied by 10, that is 16, and 1 is multiplied by 10, that is 10. That is 10 by 16 10 to the power 19, which is 0.625 into 10 to the power 19, and decimals are really expressed in this in the power of 10 by keeping one number on the left side of the decimal. So it is 6.25 into 10 to the power 18. The number of electron present in a 1 coulomb of charges is 6.25 into 10 to the power 18. It is a very big number of electrons of negatively charged particles. In the same way, if you count the number of protons present in 1 coulomb of charge, you will find the same number of protons. Students, we will conclude this part here, and next we will start another part tomorrow or day after tomorrow. Please keep on watching our videos. Till then, I want to say goodbye. Hope to meet you again in our next videos. Thank you.